In this lesson, we're going to be talking about working with textures. Now, the reason somebody would want to use textures is to create higher levels of detail that aren't possible to create with the standard KeyShot material parameters. For example, if you wanted to create a photorealistic wood grain, you could take a picture of wood and map it onto your material type and simulate a photorealistic wood grain. You could also do things that have high detail on them that aren't practical to model. For example, a textured plastic or a brushed metal. You wouldn't really go in and model the individual pieces of texture on a textured plastic, and you wouldn't model the individual brush strokes on a brushed metal. So what you do to create that is you use textures. Now, the first thing you need to understand before we go applying textures is the concept of texture mapping. Now, regardless of what 3D application you're working in, all 3D applications need to address this issue. And what it is essentially you have a 2D texture, an image file, and it needs to be projected onto a 3D model. So the 3D application needs to know how it actually does that. For example, does it project it from the top? Does it project it from the side, straight onto it? How does it actually take that 2D texture and place it onto the 3D model? So let's go ahead and double click on the material, and under the textures tab we can see our options here. So let me go ahead and load in a color map. So I've got this color applied, and let's go ahead and look at the different mapping types. First one's going to be Planar X. And to help illustrate what all these texture types are doing, I'm going to go ahead and pull up the manual. So we'll go to Help, and we'll select Online Manual. And on the left, I'm going to go ahead and navigate to the texturing section, and we're going to take a look at texture mapping. And I'll click on Planar X. So Planar X, imagine this is your 2D texture, and here's your 3D model. What it's going to do is it's going to project it on a single axis, and that is the x-axis, straight through in 3D space. So this texture gets projected infinitely in 3D space, and any 3D objects that happen to get in its way have the texture projected in that orientation. So since it is only projecting on one axis, on the other sides of the 3D model, you're going to have some stretching. So look at the top and the side, that's occurring. Let's look in our KeyShot scene here. We do have Planar X, and you can see here we got the stretching occurring. Let's go ahead and set this to Planar Y. So Planar Y is going to project it from the top, and you can see on the sides we do have the stretching occurring. We back up one and take a look at Planar Y. Here's what's going on in this case, and again, you have the stretching issue. Let's take a look at Planar Z. Planar Z is going to project it from the front, and you will have the stretching on the sides. So as you can see, these planar modes are meant more for flat objects. So for example, like a cell phone screen, maybe a tabletop, or a flat 2D sign. Things like that is when you'll want to use these planar modes. Okay, let's take a look at the next type. We'll actually skip this and we're going to jump over to box map. And let's look at what box map is actually doing. So if I click on box mapping, imagine a cube enclosing your 3D model. And each face of that cube has the texture loaded onto it. And that texture is projected from all sides of that cube. So notice with box mapping, we don't have the stretching occurring. Box mapping solves that issue. However, you will see some seams where the different projections meet up. And the projection changes essentially when you would start to see stretching. So before this projection on the side starts to stretch, box mapping is going to revert to the projection that comes down from the top to prevent that stretching. Let's take a look at spherical. So spherical is going to project it from a sphere. So if we look at our example here, imagine a sphere enclosing your model, and the texture is going to be mapped to the inside of it. Now, around the equator of the sphere, the texture is going to look really good, but as you get near the poles, the texture is going to start to converge. This will be a great type for anything spherical, and that's really what it's designed to do. Okay, and let's look at cylindrical. Okay. So what cylindrical is going to do is project it inwards from the inside of a cylinder. Okay, this will be great for anybody doing, say, jars or cans, anything that has a cylindrical label that needs to go around it. This type will be what you'll want to use. And there's one final type to look at, and that's going to be UV coordinates. Now, UV coordinates are used more in the entertainment field than they are in the CAD world. Most CAD tools do not have tools for setting up UV coordinates, so that's why KeyShot provides these automatic mapping modes. UV coordinates are a completely different mapping type than all the other types I've just shown you. There's nothing automatic about them. It's actually a quite intensive and tedious task to set up UV coordinates, but the results are really nice. So notice in this particular case we have this texture, and regardless if we're projecting it from the front or the sides, there's no stretching, there's no seams, it just lays over this really nicely. So to do UV coordinates, a 3D model undergoes a process called UV unwrapping. Essentially what happens is the model's flattened out into 2D space, and then a texture can be overlaid on top of that. And wherever that texture overlays onto that flattened model, that's where it will be projected on the 3D version. Okay, so now that we've talked about the different texture mapping types, let's talk about actually working with these textures. So the color is going to basically replace your overall diffuse color. So you can do things like wood grain, and that will work really nice. Now, when you are working with textures, it will help to understand the difference between specular and diffuse. So if you'd like some more explanation on that, inside the manual, you can go to material types and their settings, and you can read about the diffuse parameter and the specular parameter. To sum things up for you really quick, the diffuse is going to be your overall color, and the specular is going to be the color and intensity of your reflections. So, for example, if you look at my highlight here, if I go to the specular color and set that to green, notice my reflected color is green. And if I go all the way to black, I have no reflective color. And the reason I'm showing you that is because those can be mapped using textures. So what we're going to do is we're going to create a painted metal texture. So I'll go back to the original texture that I was using, and that's that painted metal color. And this is a PNG with transparency. Okay. Now what I'm doing here is adjusting the scale. So that's going to control basically how much this texture is repeated. So if your texture features are too large or too small, you can adjust the scale slider to control that. Okay. Now notice here on the material that my reflectivity is overall even. So the painted areas are equally as reflective as the non-painted areas. Now what I want to simulate here is a painted metal. So the paint would be less reflective than the metal surface. So what I'm going to do is I'm going to take the diffuse color all the way down, because metals do not have diffuse color. All their color is going to be derived from the specular. And the other thing I'm going to do is increase my refraction index by quite a bit to simulate that metal surface. Now, again, the issue we're having here is that the paint is equally reflective as the metal. So what we can do is we can load in a specular map. Now, specular map is going to use black and white values to determine areas that are more or less reflective. So if I double click on specular and load up painted metal spec, notice that we have areas now that are not as reflective as other portions. Now these maps are designed to work together. Let's take a look at how they're actually set up. So this here is here's the bump map, and this here is the specular map. So the painted areas are gray, and the non-painted areas are white. So that's going to make these dark gray areas, these are going to be less reflective, and the white areas are going to be 100% reflective. Now, since these maps are designed to work together, they're essentially the same image with some color adjustments applied. I can click on sync, and now if I adjust the scale, they both work in conjunction. So you can see here the painted areas are less reflective and specular as the metal areas. And I can add roughness to this material to roughen up the metal a bit. Alright, the next item in the list is going to be bump maps. And bump maps are going to use black and white values to simulate areas that are raised or lowered. So if this were a painted metal, the paint portion would be slightly more elevated than the metal. And let's take a look at how we're going to actually simulate that. So the white area in this texture represents the paint. The darker gray area represents the metal. The white area is going to be interpreted as more raised than the darker gray area. So if I double click on the bump texture, we can go to Painted Metal Bump, and you can see here we're simulating that bump effect. And you can control the bump height with a slider, and we'll probably just need a very subtle value here. Okay, the next texture type available to you is going to be opacity. And opacity is also going to use black and white values to determine areas that are either completely see-through or completely opaque. So black is going to be completely see-through, and white is going to be completely opaque. And of course, you can have any range in between there to simulate partial transparency. And what I'm going to do here is I'm going to load a different texture than these other textures that I've been loading here. We're going to use a circular mesh texture. So we'll click on this mesh circular alpha.jpg. And so you can see these circular holes here. Since they are black, they're going to cut out these holes in the material type itself. So we're going to simulate a painted circular mesh material. Now the opacity mode is going to be really important for creating your effect correctly. In this particular case, we're using the opacity mode as color. That basically says that, okay, anything that's black is going to be see-through and anything that's white is going to be opaque. You also have the option to choose alpha, and this will look for an alpha channel embedded in your image. If you're not sure what alpha channels are, you don't need to overcomplicate things. You can simply use images with black and white values and set your mode to color. If you are familiar with alpha channels and you will be working with those and you want to call on your alpha channel, you'll want to set the mode to alpha. And you can also do inverse color, which is going to say that white is opaque, or I'm sorry, that white is transparent and black is opaque. But we'll go ahead and stick with color here. And the other thing I would like to do, I want to scale the circles down, but I don't want the other three textures to scale with it. So what I'll have to do is I'll have to uncheck sync, and with the opacity selected, we'll go ahead and reduce the scale. And we'll have a pretty cool effect there when it's all said and done. Alright, so let's look at some of the textured materials that are found in the library. So we'll go under plastic, and let's take a look at molded texture, and we'll drag and drop one on there. So you can see we have these different textured plastic types available for you. And if you do want to adjust the scale of any of these, now you know that you can go under the Textures tab, go to your bump, and adjust the scale. One other thing to note is that if you are using normal maps, they are supported inside KeyShot. The only thing you have to do is make sure that you have normal map mode checked. Normal maps are a different image type than your standard black and white image for a bump, and it has more colors than just black and white. And basically these different colors represent varying levels of raised or lowered portions on X, Y, and Z. Now again, if you're not sure what normal maps are, you don't need to worry about it. You can simply use the black and white value bump maps for your bump effects. Alright, so that's a look at working with textures in KeyShot.